Right. This is called a Stirling engine, and it's slightly different to other engines that you might have seen. It's an external combustion engine. Its fuel source is here on the outside. What we do, we've got a wick in there. In a moment, I'll light that. The heat from the flame will heat the air up that's trapped in here. That obviously expands. As that expands, it pushes out this piston here. Right, now, you'll see the flywheel here, which is quite a weighty kind of thing, takes this lateral motion into rotational motion, which is quite a big area of physics. We don't do a huge amount of stuff, but essentially this is what changed things in the Industrial Revolution. This was the problem they had. They had lateral power, steam power, but no one had worked out a way to get rotational motion. If you think about a steam train and things moving, you need to take lateral motion, make it rotational, and then you can start moving. So they used them to like pump water out of mines and stuff like that, which was great. Hugely inefficient engines in those days, but they did the job. But if you think about a steam engine, the breakthrough piece of thinking was to stick the engine on top of what's moving. So if you think about it, you're not powering something to move along. The engine that does the power, like something like this, would be on top of a vehicle. Then you'd have some kind of drivetrain which turns the wheels and moves the power source with the object. And that's a kind of bit of breakthrough thinking. You don't really think about moving the power source along with an object. So that was your bit of breakthrough thinking. So right, that tiny bit there is key to the Industrial Revolution. Now, the amazing thing about this is it works. The thermodynamics behind it used to be part of our curriculum. It's something, if you did physics at university, you go on to study. But this is the beautiful bit. It takes the work done by the gas pushing the piston forward and turning the flywheel is more than is done compressing the cool gas. So what happens here is the hot gas moves forward, gets vented into this part here, and this big surface area in the metal allows rapid cooling of the gas. That might not seem very rapid, but it's rapid enough. The gas cools. Now, cold gas is much easier to compress. So this is what happens. The work generated here is more than it takes to compress the gas and drive the piston back. So, and this is what we talked about when we talked about work and we talked about engines and machines and the whole point of a machine. The difference in the amount of work it takes to push that piston out and to push that one back in is the work that can go into the little electric dynamo here to light the bulb. Essentially, this is how the universe works. You have to have a difference in the amount of work, because it's that difference which powers the external body. So you've got this gas expands, pushes this out, the gas gets vented, cools, and then compressed at a lower amount of work. And the spare bit of work, the extra bit of energy that you have, remember work, joules, energy, the extra bit of energy you have can be devoted to turning that dynamo and lighting that lamp, doing useful work. Now, the other thing about this is this one isn't so silent. You'll hear this one moving, like chugging along. But they're still making these types of Stirling engines, and the technology's got to such a point where they're still externally powered, heated, but these can run virtually silently because there's no explosion of gasoline in the center of the engine or diesel. They can run practically silently, and what happens is, even in Singapore and a few other countries, they can be used in submarines. Now, what happens in a submarine is, unless it's a nuclear submarine, a normal submarine, you've got a bank of batteries which need to be recharged. And if you use a diesel engine to do that, like the old submarines, you go to the surface, you start your diesel engine, chug, 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 or whatever, a lot of noise. and you recharge your batteries. At least I assume they do that on the surface. Maybe you can vent out the exhaust somewhere, you don't need to do that, but it's a lot of noise. Now this, an engine like this can be used to recharge the batteries on the sub virtually in silence. So if you can just vent the fumes out, you can recharge the batteries in the sub in virtual silence, which means from a strategic point of view, you've got a much bigger advantage. And that's why they keep making these engines for small kind of niche markets like that. But this is quite, for the simplicity of it, it's a very efficient engine in relative terms. But like I said, simple things are largely more efficient. So we're going to spark this up. Now it takes a little while to heat some of the air here. Now, it needs a little bit of inertia applied to it to get the flywheel working. And when you've got enough heat in the gas, we're close. Off we go. And if I turn that round a little bit for you, at some point, when you get enough voltage being created, you'll start seeing the little LED. If we had a little strobe lamp there, we'd be able to see the revolutions per minute there. There you go, the first flash of the LED. It's getting close, there we go. Now remember, each one of those cycles of a piston is a revolution. So when they talk about revolutions per minute, there we go.
Why is the LED turning off and on?
That'd be just the type of LED that they're going to be like one of those Christmas tree ones which changes there. And there, my friends, is the Stirling engine, and there's our energy transfer, difference between work done. Thanks very much for the present, Dad. We all loved it.
Mr. Brock, could you not use the electricity to generate more heat?
Yeah, but never enough to replace it. I mean, you'd be more likely to use that generator to cool something down, remove heat from something else, and cool it down because it serves more of a purpose.
Energy cannot be created nor
Thanks
destroyed.
very much. Bye.